Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video.
Hello everyone, in this video we're going to talk about how we can find some trigonometric values. So we did a previous video on some fundamental trigonometric identities, and we're going to expand on a couple of those in this video to find some values of other trigonometric functions of theta, given the fact that sine of theta is equal to -5/13, and it's giving us our range here, or where this theta angle would be located. It says its theta is between pi and 3 pi over 2. So let's interpret that a little bit. If we think about our unit circle and we have our axis here, our x and our y axis, then we would know this would be like 0 degrees or 0 pi, and then we would have pi over 2, and then we have pi, and then we would have 3 pi over 2, and then it would bring us all the way back around to 2 pi. So if it's telling us that theta is between pi and 3 pi over 2, well, then we see this would be quadrant 1, quadrant 2, quadrant 3, and let's fix that 3. Quadrant 3 and quadrant 4. So notice here we see pi and we see 3 pi over 2. So that's telling us that theta, our angle here, where our sine value is, where we're finding all these other trig values, that we're in quadrant number 3. And that's important because that's going to help us know the signs of these values. So now if we want to draw in here and add in kind of our triangle, well, it tells us that sine of theta would be 5/13. So we know sine is opposite over hypotenuse. So if I were to draw my terminal side of my angle in here, and then let's just add in my vertical distance. So if I put theta in here, I know that my opposite would be 5 and my hypotenuse would be 13. And we know that this would be a 5, 12, 13 Pythagorean triple, right? So 5, 12, 13, and notice that in quadrant 3, we would be going left on the x-axis, right? So that'd be like a -12. And we'd be going down for our y value, so that'd be a -5. So when we look at it this way, we see that makes sense that sine of theta should be -5/13. Okay? All right, so now let's go back and let's actually use some of these fundamental trigonometric identities in order to come up with our other 5 values. So we know sine, let's find cosine first, then we'll find tangent, then we can find the inverse of those 3 by giving us secant, cosecant, and cotangent. So if I know sine of theta is -5/13, let's use our Pythagorean identity where we know that sine squared theta plus cosine squared theta is equal to 1. So let me write that down. Sine squared theta plus cosine squared theta is equal to 1. Well, we know that sine of theta is -5/13, so we could plug that in right here. -5/13 squared plus cosine squared theta is equal to 1. Let's simplify this and then subtract it to the other side. So -5 squared would be 25, and 13 squared is 169. So now we have 25/169 plus cosine squared theta is equal to 1. Now I'm going to subtract this fraction so that now we have cosine squared theta by itself, and it's equal to 1 minus 25/169. So now if we're going to subtract the fraction, let's rewrite 1 as 169/169. So let me erase that. And let's write it as 169/169. So we do have our subtraction sign in there. And now we're going to get cosine squared theta is equal to, well, 169 minus 25. We're going to get a 144. And then we have our denominator of a 169. Now let's take the square root. And we're going to get cosine of theta is equal to positive or negative 12/13. Okay, now let's take a look back at our unit circle. And let's think about what the sign of cosine should be. Well, we have a -12 in there, and then we have a 13, right? That would be like adjacent over hypotenuse. So we know this needs to be negative. So we're going to take this away, and we're going to say it is -12/13. So now we have sine of theta, which is -5/13. That's what we started with. We have cosine of theta, -12/13. Now let's go to find tangent. So we know that tangent of theta is equal to sine of theta over cosine of theta. All right, so now we know what sine of theta and cosine of theta are. So this would be -5/13 divided by -12/13. Kind of looks a little weird, right? Well, let's multiply that. So tangent of theta would be -5/13 times 13 over -12. So now we see that our 13s will cancel out, right? and we're going to get tangent of theta is equal to negative 5 over negative 12, which would be 5 over positive 12. Okay, which if we look back at our unit circle, we could verify that because opposite over adjacent would be negative 5 over negative 12, and we would reduce that, or we would simplify that to being positive 5 over 12. Okay, now let me reduce the size of my unit circle here. Let's put it up here in the corner. And now let's find our other three values. So we know sine of theta, so let's find cosecant of theta, which would just be the reciprocal of sine of theta. So we have negative 13 over 5. Now let's find secant of theta, which would be inverse of cosine, so negative 12 over 13, not negative 12 over 13. The inverse of that, negative 13 over 12. And then cotangent of theta, which would be the inverse of tangent, so 12 over 5. Okay? All right, and that is how we can find some trigonometric values.